Hello everyone, welcome back to the channel. In the previous video, I gave you complete walkthrough of the entire Todo application that we'll be building in this series. We explored the finished app, looked at the ASP.NET Core backend, and got our starter project ready. Now it is time to start building the actual application. Today we will define how a Todo looks inside our Flutter application, create a clean API service that will communicate with our backend, and handle the errors gracefully. Once this layer is complete, every screen that we will build later will simply consume it. So let's get started. Before we create our to-do model, there is something we need to build first. If you look at the properties that we'll be adding to our model, you will notice that every to-do belongs to a category and also has a priority. So instead of storing these values as a plain text, we are going to represent them using enums. So let's start with the to-do category. Inside the models folder, create a new file called todoCategory.dart. Now create an enum called toDoCategory. Here we will define 5 categories: general, work, personal, finances, and health. Now you might be wondering, why are we using an enum instead of simply storing a string? And that's a great question. With enum, Flutter only allows one of the predefined values. That means your code becomes much safer, easier to maintain, and much less prone to bugs. Another advantage is that your ID provides auto-completion, making development faster and reducing typing mistakes. This is one of the reasons you will see enums used extensively in production Flutter applications. Next, let's enhance the user-friendliness of our enum. To achieve this, replace the comma after health category with semicolon and add a getter called name. This method returns a nicely formatted string for each enum value. We will utilize this string later to display the category in the UI. Next, let's add another helper method called toMap. Now you might be wondering why we need this. The reason is our Flutter application and our ASP.NET Core backend need to agree on how enum values are exchanged. Our backend store these enum values as integers rather than strings. For example, general as 0, work as 1, personal as 2, finances as 3, and health as 4. Instead of manually writing this conversion every time we make an API request, we centralize it inside the enum itself. Whenever we send a to-do to the backend, calling the toMap simply returns enums index. This keeps our API code much cleaner. Now let's look at the opposite scenario. When the backend sends data back to Flutter, it doesn't send the word work. Instead, it sends the integer value. For example, category 1. Our application now needs to convert that integer back to proper enum. And that's exactly what fromMap does. It takes the integer value received from the backend and returns the matching enum value. And we have also added the fallback using the or else. If for some reason the backend sends an unexpected value, our application won't crash. Instead, it safely defaults to general. Adding small safeguard like this makes our application more robust. And at this point, our to-do category enum is now complete. Next, let's build our second enum. The process is almost identical. Create a new file under models folder called todoPriority.dart and create another enum todoPriority. Here we will define 4 priority levels: low, medium, high, and urgent. Just like before, using an enum guarantees that only these 4 values can exist inside our application. No accidental spelling mistakes, no inconsistent values. Everything remains strongly typed. Next, we will again add a name getter. This simply returns a readable text that we will later display in the user interface. Next, we will also implement toMap and fromMap exactly like we did for categories. When Flutter sends the data to the API, toMap converts the enum to its integer representation, and when the data comes back from the API, fromMap converts that integer back to its corresponding enum. Again, notice that we are providing a default value of medium if an unexpected number is received. And at this point, our to-do priority enum is now complete. Alright, now that our to-do category and to-do priority enums are ready, we have everything we need to create the actual to-do model. So inside the models folder, let's create a new file called todo.dart. And inside this file, let's create a class called todo. Now that we have created our to-do class, let's take a closer look at each property and understand why it's there. Remember, this model represents a single to-do item throughout our application. Whenever we receive data from the backend or send data back to it, we always work with this model. So let's start with the first property, which is ID. This is the unique identifier of a to-do. One important thing to notice that it's nullable. Why? Because when the user creates a brand new to-do, Flutter doesn't know what its ID is. The backend generates that value for us. So when we send a post request to create a new to-do, this field will be null. After the backend successfully saves the to-do, it returns the generated ID. And from that point onward, we will use it whenever we edit, delete, or mark the to-do as completed. In short, this property uniquely identifies every to-do in our application. Next is the title. This is the most important property of a to-do. It is the text that users immediately see in the to-do list. For example, respond to emails. Since every to-do should have a meaningful title, we have made this field required. Without a title, the to-do wouldn't make much sense. The next property is description. Unlike the title, this field is optional. Sometimes a short title is enough, but for larger tasks, user may want to include additional details. For example, instead of just simply writing respond to emails, they might include reply to pending work and personal emails. Next is it's completed. This property tells us whether the task has been completed or not. Initially, every new to-do starts with the value false. Later in this series, when user taps the checkbox, we will simply update this property to true from false. Instead of deleting the completed task, we will preserve them and use this flag to determine how they should appear in the UI. Next, we have to-do category. And now you can see exactly why we created the to-do category enum before creating our to-do model. Instead of defining the category as a string, we are directly using our to-do category type. This means a to-do can only use one of the categories defined inside that enum. Later, we will use this property to display the to-dos category and even filter to-dos by category. Next is to-do priority. This property represents the importance or urgency of a to-do. Again, we are using the to-do priority enum that we have created earlier. Later, we will use this property to display the to-dos priority and even filter to-dos by priority. Next, we have due date. Not every to-do needs a deadline. For example, drink more water probably doesn't require one. But something like schedule doctor appointment definitely does. And that's why this property is nullable. If a user chooses a due date, we will store it here. Otherwise, it simply remains null. Next, we have reminder date. Now, due date and reminder date may sound similar, but they represent two different concepts. The due date answers the question, when should this task be completed? The reminder date answers, when should I remind the user about this task? Let's say I need to submit a project report on Friday. Friday is my due date. But reminding me on Friday when the report is already due might not be very useful. Instead, I might want a reminder on Thursday morning. So, to-do can have a due date on Friday and a reminder date on Thursday. These are two separate pieces of information. And just like due date, reminder date is also optional. Not every to-do needs a reminder. So, we are making this property nullable as well. Next, we have date created. This property represents when the to-do was originally created. This value is managed by our backend. When we send a request to create a new to-do, we don't need to manually set the creation date from Flutter. Our ASP.NET Core API handles that for us. Once the to-do is created, the API returns the creation date as a part of the response. We will then convert that value into that datetime object and store it here. And the final property is date updated. This tells us when the to-do was last modified. Date created tells us when the to-do was originally created, and date updated tells us when it was most recently changed. Just like date created, this value is managed by our ASP.NET Core backend. Flutter simply receives it as a part of the API response. Alright, now we have all the properties required for our to-do model. So let's create the constructor. You will notice title is completed, category and priority are required. That's because every to-do needs these values. The ID is optional because it is generated by our backend. Description, due date and reminder date are optional because user may not provide them. And date created and date updated are also optional because those values are generated and managed by our API. Also notice that all the properties are marked as final. This makes our to-do model immutable. Once a to-do object has been created, we don't directly modify its properties. Instead, whenever something changes, we work with an updated to-do object. This makes state changes much more predictable and becomes especially useful when we start working with the provider later in this series. So our to-do model is now ready. But we have a small problem. Our ASP.NET Core API doesn't know anything about Dart object. When we fetch todos from the API, the backend sends us a JSON. And when we create or update todo, the API also expects JSON data in the request body. So we need a way to convert between our JSON data and to-do model. In other words, we need to handle two directions. We need to convert the data coming from the API into to-do objects. And we also need to convert a to-do object into data that we can send back to the API. Now we can write all of this mapping code manually. But honestly, most of it is a repetitive boilerplate. So instead, I'm going to use the Dart data class generator extension for Visual Studio Code by Ricardo Emerson. If you don't have this extension already installed, open up Extensions panel in Visual Studio Code and search for Dart data class generator. I have already installed this extension, so let's go to the to-do class and open up the quick fix menu. And here I'm going to select the option generate JSON serialization. And there we go. The extension has generated the serialization code for our to-do model. But before we move on, let's understand what these methods actually do. Because I don't recommend generating the code and simply assuming everything is correct, especially when you are communicating with an API. You should always compare the generated mapping code and the actual request and response format used by your backend. We will see exactly why in just a moment. Let's first look at the fromMap. The fromMap factory constructor receives a map. Now, when we decode a JSON response in Dart, we commonly end up working with this type of map. The key represents the JSON property names and the values contain the actual data. So the responsibility of fromMap is very simple. Take this map, read the individual values and create a to-do object from them. Now there are few changes we need to make to the generated code. Let's look at our date properties. And this is where we need to be little careful. Mapping code for the datetime properties is generated using datetime.fromMilliseconds since epoch. The idea behind this code is that the date value is expected to be an integer, representing the number of milliseconds since the Unix epoch. So the generated code expects a value similar to this. This is the timestamp represented in milliseconds. And if our API returned dates in this format, the generated code would have worked perfectly fine. But that's not the format used by our ASP.NET Core API. Our API sends date and time values as ISO 8601 strings. So instead of receiving an integer timestamp, we will receive a value that looks something like this. This is a string representation of date and time. So we need to update the generated code. And this is really an important lesson whenever you are using code generation. Generated code doesn't automatically understand your backend contract. The generated code only looks at the Dart properties in your class. It knows that the due date is date time, but it doesn't know whether your API represents the date as milliseconds, an ISO 8601 string, or some completely custom date format. That's something we need to verify ourselves. Since our API sends ISO 8601 date strings, instead of using datetime.fromMilliseconds since epoch, we will use datetime.parse. And we will apply the same approach to other datetime properties. Now that our fromMap constructor is ready, let's look at the fromJson constructor. This factory constructor receives a JSON string. First, we use json.decode to decode that string. After decoding, we get the map containing our to-do data. And instead of duplicating all the mapping logic again, we simply pass that map to todo.fromMap. So the flow is JSON string gets decoded into a map and the map is then converted into a to-do object. Now let's look at the opposite direction. So far, fromMap and fromJson help us convert the data received from our API into the to-do object. But when we create or update a to-do, we need to send our to-do data back to the ASP.NET Core API. And that's where toMap and toJson method comes in play. Let's start with toMap. The purpose of this method is to convert our to-do object into a map. For simple properties like ID, title, description, and is completed, we can directly add their values to the map. But for categories and priorities, we are calling their toMap methods. Remember, inside our Flutter application, these are enums. but our API expects their integer values. So these methods convert the enum into the correct integer representation before sending the data to our backend. Now let's look at due date and reminder date. The data class generator originally converted these datetime values using milliseconds since epoch. But there is a problem. Our ASP.NET Core API expects date values in ISO 8601 format. So instead of sending a number representing milliseconds, we need to send a date string in the format expected by our API. To fix this, we will replace milliseconds since epoch with to ISO 8601 string. We will make the same change for reminder date. Notice we are using null aware operator over here. So if the due date or reminder date is null, we will simply send null. Otherwise, that converts the datetime values into an ISO 8601 string. Next, we will remove date created and date updated properties from the toMap. And this is intentional. Remember, both of these values are managed by our backend. When a new to-do is created, the ASP.NET Core API sets the creation date, and whenever the to-do is updated, the backend manages the updated date. Flutter doesn't need to send or control these values. We only receive them from the API. And finally, we have toJson. This method simply calls toMap to convert our to-do into a map and then passes that map to json.encode. The result is a JSON string that we can send in the body of an HTTP request. So the flow is very simple. Our to-do object becomes a map and the map becomes JSON. And with that, our to-do model can now correctly convert data in both directions between the Flutter and our ASP.NET Core API. Alright, our to-do model can now convert data to and from the format expected by our API. But later, when user edits a to-do or marks a task as completed, we will need an easy way to create an updated version of the existing to-do. Remember, all the properties in our model are final, so we can't directly modify them after the object has been created. Instead, we will create a new to-do object with the updated values while keeping the rest of the values unchanged. And this is where the copyWith method becomes useful. Once again, we will use the Dart data class generator extension of Visual Studio Code and generate the copyWith method. So for that purpose, open up Quick Fix menu and select Generate copyWith. And there we go. The extension has generated the copyWith method based on the properties available in our to-do class. The idea behind copyWith is very simple. It creates a new to-do object while keeping the existing values by default. We only provide a new values for the properties we want to change. This works because inside the method we are using null coalescing operator. If a new value is provided, the value is used. Otherwise, the value from the current to-do object is used. This gives us a clean and convenient way to create an updated version of our immutable to-do object. But before we move on, there is one small change I want to make to the generated method. Let's remove the date created and date updated from the copyWith parameter and from the to-do object created inside this method, as these two values are managed by the ASP.NET Core backend. Next, I want to add a dedicated factory constructor for creating a new to-do called Todo.create. Now, why do we need this when we already have a constructor? The main constructor represents the complete to-do model, including properties like ID, date created, and date updated. But when the user creates a new to-do, we don't need to provide these values. The ID, creation date, and updated date are all managed by our backend. We can also provide some default values for a new to-do. For example, for category, we can use general as a default category. And for priority, we can use medium as a default priority. And a newly created to-do should obviously start as incomplete. So incompleted defaults to false. Inside the factory constructor, we simply create and return a to-do object using these values. This gives us a clean and intentional way to create new to-dos. It also keeps the rules for creating new to-dos in one place. Finally, let's override the toString method. Again, we will use the Dart data class generator extension for Visual Studio Code to generate the toString method. So for that purpose, open up Quick Fix menu and select Generate toString. And there we go. Now you might be wondering why we need to override the toString method. It's because by default, if we try to print a to-do object, we get a message instance of to-do. And that's not very helpful when we are testing our API or debugging the application. By overriding the toString, we can return a readable string containing the todo properties. So now when we print todo object, we can immediately inspect its ID, title, completion status, category, priority, dates, and other values. This will be especially useful in few minutes when we start testing our API service and print the todo objects written by the backend. And with that, our todo model is now ready. Now let's move on and define the service responsible for communicating with our ASP.NET Core API. But before we start writing HTTP request, I want to define a contract for our Todo service. So inside the services folder, create a new file called todoservice.dart. And inside this file, let's create an abstract interface class called TodoService. Now you might be wondering why we are creating an interface. Why not simply create a class and start writing our HTTP calls? The reason is separation and flexibility. Our application needs to perform a set of to-do operation. It needs to fetch to-dos, create new to-do, edit an existing to-do, toggle its completion status, and delete to-do. The to-do service interface simply defines that contract. It tells the rest of our application what to-do operations are available, but it doesn't decide how those operations are implemented. For example, today we are using an ASP.NET Core REST API. But imagine that later we decide to store to-dos locally, or maybe we switch to Firebase. The implementation will change, but the operations required by our application remain the same. We still need to get, create, edit, toggle, and delete to-dos. That's why defining the interface first gives us a clean abstraction between the application and the actual data source. Now let's start with GetTodos. This method returns a future list of to-do. It will asynchronously fetch all to-dos and return them as a list of to-do objects. Next, we have addNewTodo. This method accepts a to-do object and return the to-do created by our backend. We are returning a to-do because the server can add the backend managed values like the ID, creation date, and updated date. Next is editTodo. It accepts the to-do that we want to update and returns the updated to-do from our API. Then we have toggleTodo. This will be responsible for updating the completion status of a to-do. Again, it accepts a to-do and returns the updated to-do. And finally, we have deleteTodo. This method only needs the ID of the to-do that we want to delete. It returns a future void because once the operations complete successfully, we don't expect any to-do data back. In the next step, we will create a separate class that implements this interface. This class will contain the actual HTTP logic and communicate with our locally running ASP.NET Core API. So let's create that implementation next. Inside the services folder, let's create a new file called todoservice API impl.dart. And inside this file, let's create a class todoservice API impl and implement our todoservice interface. Next, let's define the base URL of our API. My ASP.NET Core application is currently running on port 5159 and all our to-do endpoints are accessible under the /API route. Therefore, the base URL of our API is localhost:5159/API. However, accessing a locally running API from a Flutter application differs slightly depending on whether we are using the iOS simulator or Android emulator. For the iOS simulator, we can use localhost, but for the Android emulator, we can't use localhost. Instead, we need to use a special IP address 10.0.2.2. So to handle both platforms, first we will check if we are running on iOS using platform.isiOS. If yes, then we will use localhost. Otherwise, we will use 10.0.2.2 for Android. Now our service knows where the API is running. Let's implement our first method and fetch the to-dos. But before writing the HTTP request, let's quickly open Scalar and look at the GetTodos endpoint. Let's click on test request. Here we can see that it's a GET request. We can also see the endpoint URL. Let's click on send. And this is the response written by our ASP.NET Core API. Notice that the actual list is available inside the data property. Keep that response structure in mind because we will use it while parsing the response in Flutter. Now let's go back to our service and implement the first method from our service, GetTodos. I'm going to paste the implementation here and then let's quickly walk through the code and understand what's happening. The first thing that we are doing is sending a GET request using http.get method. We build the endpoint by combining our base URL with /todos and convert it into a URI by using URI.parse. And since making an HTTP request is an asynchronous operation, we use await to wait for the API response. Once we get the response, we check its status code. If the status code is 200, that means the request was successful and we can process the response body. Now, if you remember the response we saw in Scalar, the actual list of to-dos is available inside the data property. So first we use JSON decode to convert the JSON response body into a Dart object. Then we access the data property and cast it to a list. At this point, we have a list of to-do data, but each item is still just a map. So we use map to iterate through the list and pass every item to todo.fromMap. Our to-do model then handles converting each map into a strongly typed to-do object. And finally, we call toList to return the result as a list of to-do. So the flow is quite simple. We send a GET request, decode the JSON response, extract the data list, and convert every item into a to-do object. If the API doesn't return 200 status code, for now we are just simply throwing an exception. We will improve this error handling shortly by creating custom exceptions for different failure scenarios. But first, let's make sure GetTodos implementation is actually communicating with our ASP.NET Core API and returning the expected to-do objects. For testing, I have already added a simple fetch todos button on our to-do screen. If you look at the handle button press method, I have created an instance of TodoService API IMPL. Then we are calling the GetTodos method and storing the return list in the todos variable. And finally, we are printing the result to the debug console. This is only temporary testing code. Later in the series, provider will call our service and manage the to-do state for the UI. But right now, we simply want to verify that our API service is communicating correctly with the backend. Now let's tap on the Fetch Todos button. And if you look at the debug console, perfect. We can see the list of to-do objects written by our API. And because we override the toString method earlier, we can clearly inspect the data for each to-do instead of seeing a generic instance name. So this confirms that our GetTodos implementation is working correctly. But our current error handling is still very basic. If something goes wrong, we are simply throwing a generic exception. So next, let's improve this by creating a custom exceptions for different types of errors. The problem with generic exception is that it makes error handling much harder. Think about it. An API request can fail because the server returned an error. The request might be invalid. The to-do we were looking for may not exist, or the application is not able to connect to the API because of network issue. If all of these failures are represented using the same exception type, the rest of our application has no clear way to understand what kind of error actually occurred. So let's create a new file called exceptions.dart inside core errors folder. First, let's create an app exception. This will be the base exception for all the custom exceptions in our application. It implements Dart's exception interface and contains a message property. We have also overridden the toString method and simply returning the message. This gives all our custom exceptions a consistent structure and allows us to define meaningful error messages. Next, let's create the server exception. We will use this exception for server-side failures. In terms of HTTP status codes, these are generally responses in the 500 range. For example, 500 internal server error, 502 bad gateway, or 503 service unavailable. These status codes tells us that request reached the server but something went wrong while processing it. So for these failures, we will throw a server exception. Next is BadRequest exception. We will use this when our API returns a 400 bad request. This means the server received our request, but the request itself is invalid. For example, we may send incorrect data or the request may fail the validation rules defined by our ASP.NET Core API. Next, let's add resource not found exception. We will use this when our API returns 404 not found. For example, imagine we fetch a to-do and then someone deletes that to-do from the backend. If we later try to update or delete the same to-do, the API may return 404 because that resource no longer exists. Instead of treating this as a generic error, we will represent it using resource not found exception. Next, let's create network exception. We will use this when our application is unable to connect to the API because of the network related problem. For example, the device may not have a network connection or our locally running API may not be reachable. And finally, let's add unknown exception. This will act as our fallback exception. If something unexpected happens and the error does not match any of the known scenarios we have defined, we will wrap it as an unknown exception. That way, even unexpected errors are handled consistently by our application. Our getTodos method is working correctly, and we also created our custom exceptions. But before we move forward, there is one problem. Every method, addNewTodo, editTodo, deleteTodo, and toggleTodo will send an HTTP request. Every method will check the response status code. Every method will need to map HTTP status code to our custom exceptions. And every method will have its own try catch block. The only thing that actually changes from one method to other is the HTTP request itself and how we process a successful response. Everything else is identical. So instead of duplicating the same logic in every API method, let's move the common functionality into reusable helper methods. We will create one helper to process the HTTP responses and other helper to handle exceptions. This will make the remaining CRUD operations much smaller and much easier to read. Let's start with the handle response method. The purpose of this method is to centralize all our HTTP response handling. Instead of every API method checking status codes individually, they will all delegate that responsibility to handle response. This method is generic, so it can work with any return type. Whether an API method returns a to-do, a list of to-do, or even void, we can reuse the same implementation. The second parameter is a callback called onSuccess. If the request is successful, we will invoke this callback and let it decide how to convert the response body. For example, in getTodos, the callback will convert the response into a list of to-do. Later, when we implement addNewTodo, the callback will convert the response into a single to-do. Now let's look at the status code. If the response status code is in the 200 range, the request was successful. So we decode the response body and pass it to the callback. If the API returns 400, we throw BadRequest exception. If the API returns 404, we throw resource not found exception. And if the status code is in the 500 range, we throw a server exception. Anything else is treated as an unknown exception. So now all our HTTP response handling lives in one place. If we ever need to support another status code in the future, we only need to update this single method. Now let's create our second helper method, execute. While handle response deals with the HTTP responses, execute is responsible for exception handling. This method also uses generics, so it can wrap any API operation regardless of its return type. It accepts two parameters. The first one is the action that we want to execute. This is simply the API request. The second parameter is a context string. We will use this to provide more meaningful information if an unexpected error occurs. Inside the try block, we execute the action and return its result. If one of our custom exception is thrown, we simply rethrow it because it's already the exception type we want. If a socket exception occurs, we will convert it into a network exception. This gives the rest of our application a clean application-specific exception instead of exposing low-level networking exceptions. Finally, if an unexpected error occurs, we will wrap it inside an unknown exception along with the operation context. Now, every API method automatically gets the consistent exception handling without duplicating try-catch blocks. Let's update our getTodos implementation to use these helper methods. Notice how much cleaner the method looks now. The method is no longer concerned with handling status code or managing exceptions. It simply performs the get request and defines what should happen when the request succeeds. Everything else is handled by our reusable helper methods. This makes the method much easier to understand because it focuses on single responsibility, and that's exactly what we want. Next, let's start with the addNewTodo method. But before writing the implementation, let's quickly open Scalar and look at the create to-do endpoint. Let's click on test request. Here we can see that the endpoint uses HTTP post method. It also shows us the request body that the API expects. So let's provide some detail and let's hit send. And this is the response that will be written after successfully creating a to-do. Understanding the API contract first makes the implementation much more straightforward. Now let's switch back to Flutter, and here is the implementation for addNewTodo. Now let's go through it. Just like before, we wrap everything inside execute. This automatically gives us consistent exception handling for this API call. Inside the action callback, we are sending HTTP post request using http.post. The request URL is our base URL followed by /todos endpoint. Unlike GET request, a post request sends data to the server. That's why we are also passing two additional parameters. The first is the content type header. We are setting it to application JSON to tell the server that we are sending JSON data in the request body. Next is the body itself. Our API expects JSON, but our Flutter application is currently working with a todo object. So first we call todo.toMap to convert the todo object into a map. Then we use JSON encode to convert the map into a JSON string. This JSON string is what gets sent to our ASP.NET Core API. Once the server processes the request, it returns the newly created todo. Just like we did in GetTodos, we will pass the response to handle response. If the request is successful, the callback extracts the data property from the response and convert it into a todo object using todo.fromMap. Finally, the newly created todo is written back to the caller. Now that we have implemented the addNewTodo method, it's time to test and make sure we can successfully create a new todo from our Flutter application. I have already updated the test button on the todo screen. This time, instead of fetching the todos, we are creating a new todo using the Todo.create factory constructor. I have provided title, description, category, priority, due date, and reminder date. Then we are passing that todo to our addNewTodo method. Finally, we print the todo written by the API so that we can verify that the operation completed successfully. Now let's click on the addNewTodo button. And instead of creating a new todo, here we are getting an error. An error occurs while creating a new todo. Converting object to an encodable object failed. The request body is created using JSON encode todo.toMap. That means the problem is most likely somewhere inside our toMap method and related to the date properties, as toISO8601 string is mentioned in the error message. So let's open up todo.dart and take a look. And here is the issue. Instead of calling toISO8601 method, we accidentally reference the method itself. So let's fix that. Hit save. And now let's click on the addNewTodo button one more time. Perfect. This time the request completes successfully. If we look at the debug console, we can see the todo written by our ASP.NET Core API. Now that we have successfully created a new todo, let's implement the editTodo method. Before writing any code, let's first understand how this API works using Scalar. This is the GetTodos endpoint. Notice that the todo we created in the previous section is now part of the response. I'm going to use this todo for our update operation. Now let's switch to the updateTodo endpoint. Here we can see that the endpoint uses HTTP put method. One thing to notice is that the endpoint requires the todo ID as the part of the URL. This tells backend exactly which todo needs to be updated. I have already provided the ID of the todo we want to update and modified its title in the request body. Now let's click send. Perfect. The API has successfully updated the todo and returned the updated object in the response. To verify the changes, let's switch back to the GetTodos endpoint and click on send once again. As you can see, the updated title is now reflected in the list of todos, confirming that update operation was successful. Now that we understand how the API works, let's implement it in Flutter. Here is the implementation of editTodo method. Let's go through it together. If you compare this implementation with addNewTodo method, you will notice that most of the code looks familiar. We are still wrapping everything inside execute, which means we automatically get consistent exception handling. And once the request complete, we are still using handle response to process the server response. The only thing that change are the HTTP method and the endpoint URL. That's one of the biggest advantages of creating those helper methods earlier. Now that our editTodo implementation is complete, it's time to test and verify that we can successfully update existing todo from our Flutter application. I have already updated the button on the todo screen to test this functionality. Let's quickly walk through what happens when we press this button. First, we are calling GetTodos to fetch all todos from our backend. Once we receive the list, I am printing the first todo in the list in the debug console. This allows us to see its current values before making any changes. Next, I am creating an updated version of that todo using the copyWith method. Notice that I am not creating a brand new todo object from scratch. Instead, the copyWith creates a new todo by copying all the existing values and only replacing the properties that I want to update. In this example, I'm updating title, description, each completed, and priority, while everything else like category, due date, and reminder date remains unchanged. Finally, I'm passing this updated todo to the editTodo method and printing the todo written by the API. Now let's click the editTodo button. If you look at the debug console, the first thing we see is the original todo that was fetched from the API. Notice its title, description, each completed, and priority. Now immediately after that, we can see the updated todo written by our API. The title, then description, each completed, and priority has been updated, and the remaining properties are preserved. This confirms that our update request was successfully processed by the backend. Now let's implement toggleTodo method. Here is the implementation. And now let's understand why it's so simple. Notice that we are not writing another HTTP request here. That's because toggling a todo is essentially just updating its completed property. And we already have an editTodo method that knows how to update an existing todo. So instead of duplicating the same put request, we are simply calling the editTodo and passing the updated todo object. Now it's time to implement the final CRUD operation, deleting a todo. Before writing any code, let's first understand how the deleteTodo API works using Scalar. Here is the GetTodos endpoint, and this is the list of todos written by the API. We will delete the first todo in the list. So let's copy its ID. Now let's switch to the deleteTodo endpoint. This endpoint uses HTTP delete method. Unlike the create or update endpoints, it doesn't require a request body. Instead, it only needs the ID of the todo, which is passed as the part of the endpoint URL. Let's paste the ID of the todo we want to delete and click send. Perfect. The API has successfully deleted the todo. To verify the result, let's go back to the GetTodos endpoint and click send once again. And as you can see, the todo we just deleted is no longer present in the response, confirming that the delete operation was successful. So the overall flow is straightforward. First, identify the todo you want to delete, then copy its ID, pass the ID in the endpoint URL, and finally send the request to delete the corresponding todo. Now that we understand how the deleteTodo API works, let's implement it in Flutter. Here is the implementation of deleteTodo method. Now let's go through it together. Just like the other CRUD methods, we are wrapping everything inside execute. So we automatically get consistent exception handling. Inside the action callback, we are making HTTP delete request using http.delete. The request URL is our base URL followed by /todos and the ID of the todo that we want to delete. Once the request completes, we pass the response to handle response. Since deleting a todo doesn't return any todo data, this method returns future void. So if the request completes successfully, there is nothing else to process. And just like the rest of our service methods, any responses are handled automatically by our reusable helper methods. Now that our deleteTodo implementation is complete, it's time to test and verify that we can successfully delete a todo from our Flutter application. I have already updated the deleteTodo button on the todo screen with the required code. Let's quickly walk through what happens when we press it. Inside the button handler, we are simply calling the deleteTodo method and passing the ID of the first todo in the list for deletion. Once the request completes successfully, we are printing a confirmation message to the debug console. Now let's run the application. Now let's click on the deleteTodo button. In the debug console, we can see a confirmation message that confirms the success of the delete request. However, whenever working with APIs, it's always a good idea to verify the result rather than assuming everything worked as expected. So let's switch back to Scalar. Here is the GetTodos endpoint. Let's click on send. Here we can see that the todo we deleted is no longer in the list, which confirms that our delete request successfully removed it from the database. And with that, we have successfully implemented and tested all the CRUD operations in our TodoService. In the next video, we will create our very first provider, Todo provider, and integrate our first API method, GetTodos, to start displaying the real data in our Flutter UI. Thank you for watching this video, and I will see you in the next one. Happy coding!